Thank you so much for having me here. Today I'll talk about hybrid physics AI and entrepreneurship in climate and sustainability. And I have somehow grandly titled it From Massachusetts to the World. So I'm representing my SDS lab, Sustainability and Data Sciences lab at Northeastern University, and AI Forecast, that's AI for Climate and Sustainability, within the Institute for Experiential AI, also at Northeastern University. And again, thank you very much for having me here. I have my affiliations on the left, and on the right, my funding acknowledgements. I'll not spend too much time on those, but go right into what I was going to talk about. First of all, I want to set a little bit of expectations. So since we are talking about, I'm calling from Boston, and you are in Korea. So we wanted to talk a little bit about AI and sustainability in Asia and the world. By the way, I did want to be there virtually, but because of some family urgencies this Sunday, I am not able to be here. But what I'll try and do is I'll come back during the Q&A, either at the end of the entire session or at the end of my talk. And you have my apologies for that. This was a bit unforeseen, and that's why I thought I'll record it and put it up there. So one question is, as you think of AI and sustainability, does this have to be a zero-sum game of some winners and some losers? How is the world looking right now? So this was 2017, quite a few years back now. This is MIT Technology Review. They called this the artificial intelligence issue. And again, I wanted to talk a bit about Asia, a bit about US, and potentially the world. So here I just highlighted, they had a few articles in this artificial intelligence issue. A couple of articles illustrate the divide, even within one continent. So here, this article was about China. They called it China's AI Awakening. And look at the subtitle, The West Shouldn't Fear China's Artificial Intelligence Revolution. It should copy it. So that is the MIT Tech Review saying that. On the other hand, on the right, this is India. There was an article about India, and it says, India warily eyes AI. Technology outsourcing has been India's only reliable job creator in the past 30 years. Now artificial intelligence threatens to wipe out those gains. So look at the divide already existing in even one part of the world. And this is something we'll come back to again. Now, if we think of sustainability, if we think of climate adaptation, which is one of the things that I work on. So here are the leaders, middle of the pack, and laggards. And you'll see the leaders are Canada, Europe, Australia, Japan, Korea. And the laggards are Russia, Saudi Arabia, some parts of South America, South Africa, etc. And USA, India, China, all are somewhere in the middle of the pack. And in terms of the Climate Adaptation Index, Canada leads the pack, followed by Singapore, followed by South Korea. So it's interesting already how climate adaptation is being done across the globe. And then if we think of leading countries in terms of installed renewable energy, so this here we talk about climate mitigation now, China is the clear leader by far. And from what I have read, and this leadership is not just in view of the desire to do good to the world through climate mitigation. I'm sure that's maybe one part of it, but it's also a solid business investment. And then if we think of metro rail network infrastructure, just to pick one infrastructure which is often impacted by climate-related extremes, we see in terms of leaders, China, US, India, Russia, Japan, South Korea, UK, etc. US has been a traditional leader, but look how some of the leaderboard is changing. Similarly, if we think of electric vehicles, as all of you know, China's BYD has overtaken Elon Musk's Tesla as the world's top electric vehicle seller. This was January 2025. All right, so one thing here also is that if we think of the recent surge or continuing surge in the US stock markets, there was an interesting article in the New York Times which said that AI has held up Wall Street in 2025, and they're asking, will that continue? Interestingly enough, one of the issues, one of the key challenges, not the only one, but one of the challenges when it comes to AI and continuity of AI is critical minerals, things like rare earths. So the artificial intelligence boom, which holds up or held up the US stock market, depends a lot on rare earths. And what is the situation there? If you look at the top right, this is China's 6-decade campaign to dominate rare earths. And in the middle, they're talking of this is ASP, the an American security report talking about the new Cold War, rare earths, AI, and strategic competition with China. And then bottom right, they're also saying, well, this is New York Times saying, well, Japan has built a rare earth supply chain without China. So clearly, this is not all complementary, not all cooperation, but there is a zero-sum kind of approach emerging, which is a bit unfortunate for all players considered. Now, one other aspect beyond rare earths, if we look at semiconductor manufacturing, clearly that's also very much scattered. And the top 5 countries, as we all know, Taiwan is number 1, South Korea, your country, is number 2, Japan is 3, the US, which used to be an undisputed leader, is now number 4, and China is quickly catching up, and it's number 5. So again, Asia and the North America, I would say especially US, seems to be dominating in all of these areas. What to do about it? So one thing, I mean, we hear about foundations, what to do about all of these things, whether it's AI, but especially AI in the context of sustainability and even health kind of sciences, how to make a difference. So people talk about foundations, people talk about, various kinds of federal government, state governments, local government. Here is one individual, Larry Ellison. By the way, full disclosure, I used to work at Oracle Corporation for 5 to 6 years. But Larry Ellison, this is a New York Times article, he wants to do good, do research, and make a profit, address issues like health, hunger, and climate change. But he wants to do it a bit differently. He wants to focus his resources on philanthropy, yes, but in a way that also makes profit. So he thinks at least that foundations, nonprofits have not been able to deliver as much as they should. All right, now let's go to the sustainability challenges. I'll talk about Nobel Prize and ignoble action. So when you think of sustainability, we think about the Sustainable Development Goals of the United Nations. There are 17 such goals on the left. Many of you are already aware, so I'll not go through those. But one thing I wanted to highlight on the right is that climate action, which is number 13, has often been thought of as the central aspect of these UN SDGs, Sustainable Development Goals. Climate action is seen as central to all of these efforts. Now, if we think about climate and atmospheric science broadly speaking, let us think of a couple of examples. So if we think about ozone hole problem, which is also atmospheric science, which is related to the kind of things we do often, at least in one part of climate. If we look at the top part, on the left, a Nature paper came out in 1974. 14 years later, 1989, the Montreal Protocol for ozone hole, controlling ozone hole, came into effect. 1995, the Nobel Prize in Chemistry was awarded. 14 years from science to action, and action to Nobel in 7 years. And even now, these things are being discussed by the United Nations. So, for example, I'm part of a committee which looks at the intersection of ozone hole with climate change. Now let's look at climate change. Here, things seems to have progressed in exactly the other way. It's not science to action to Nobel Prize. The first Nobel Prize awarded in 2007 was for action. and that was to the IPCC for assessing the state of the science, and Al Gore for science communication. Climate adaptation caught up, took 11 years just in terms of Nobel years, 11 years to catch up when the economics Nobel was awarded to climate. And then the climate science, which ideally would drive everything, there was a Nobel Prize in Physics awarded in 2021. So that took 3 years again to catch up. So the impacts first, and then adaptation, and then the science. And one would think, what is going on? This doesn't look like the right kind of sequence. Well, climate science is complicated, climate action is complicated, adaptation is complicated, which is probably one of the reasons why there is some level of lack of buy-in, especially in the US, but also to some extent across the world. And these things need to be addressed, of course, as all of us know. The other thing is that although when we think about climate, the world is very much connected. Something happening, some El Nino event or some other phenomena happening in one part of the world may impact weather patterns in another part of the world. Carbon dioxide molecules released in one part may impact another part, etc., etc. However, in terms of economy, the world is very much divided. So here we see the emerging economies. This is on the y-axis per capita emissions, on the x-axis human development index. We see some of the emerging economies in the bottom left and some of the developed economies in the top right. And we also see that there are economies which are equally well developed, sometimes more developed, such as Scandinavian countries, and include South Korea in that, but which do not need as much per capita emissions, for example, as the US, definitely not like Qatar and Singapore, for example. Food for thought. And the other thing is that when we think about adaptation and mitigation, mitigation has been called avoiding the unmanageable. Adaptation has been called managing the unavoidable. Adaptation talks about resources, managing hazards. Population straddles adaptation and mitigation. All of that informs emissions negotiations. And each region or country ultimately thinks about their own resources, their own hazards and critical infrastructures, their own population in their discussions on emissions. So that's just the ground reality. Question is, how do we work despite some of those kind of situations? And the other thing is the world is very much connected these days. So natural systems, such as here in the context of India, natural systems such as monsoons, together with human policy decisions such as how much groundwater I should extract, what kind of policies we should have to enable groundwater extraction, what does that mean for groundwater, but also what does that mean for electricity users and stresses on the power grid, what does that mean for lifeline networks such as rail. All these things are very much interconnected these days. Now, the thing, though, is, we have been talking, I just spoke about the Nobel Prize. I also promised to speak about the Ig Nobel Prize. Now, the thing is, there are many things happening. Politics, of course, does impact things like climate very strongly, right? As we all know. And unfortunately, in the US, we are sort of getting away from global cooperation, withdrawing from key climate treaties, etc. There must be some bigger wisdom here than I can understand, but and there is this issue with Nobel Prize, Nobel Peace Prize, etc. Anyway, ignoring all of that, and this is not connected to all the other things that I just discussed, but just for humor, there is something called the Ig Nobel Prize. It's a satirical prize, which is a spoof on the Nobel. Incidentally, only once in the history of Nobel Prizes and Ig Nobel Prizes has a person got both prizes, but for very different kind of discoveries. Anyway, coming back to our own research. So one thing about climate research, especially I work in climate adaptation, the research needs to transcend barriers. So some of the disciplinary boundaries that were created maybe in Europe even before the industrialization age is just not adequate. Those disciplinary boundaries are just not adequate to solve the emerging problems of this century and beyond. And a lot of the important societal challenges seem to be at the interfaces. And this is true for climate change. So here, my research, at least, the focus is adapting to a changing planet. And it necessarily means climate science at the interfaces. I have civil and environmental engineering sciences in the forefront because that's my discipline. And within that, more on hydrology and a bit on transportation and some on meteorology. So here are all my papers and such in the different venues. And of course, the areas of my training, which is hydrology, some meteorology, bit of transportation, they dominate. But you see how much they have spread now into ecology, policy, marine sciences, and that's the nature of the field of climate these days. And one question that I have often been asked is, okay, but what do you really do? Are you this engineer or that? So I've been struggling to answer this question, where to draw the line to make, let's say, engineering disciplines uncivil. There's a saying in engineering that if you have to be an engineer, why not at least be civil? But where do you draw the line, especially if you're trying to solve societal problems such as climate adaptation? The other aspect is, even in terms of the methods, we have methods for big data where machine learning may be relevant. We have methods for small data, such as for rare events and small samples. Big data, generative AI for weather forecasting, computer vision in the context of climate, extremes such as rare events, in the context of or 100-year events in the context of hydrology, weather, climate, and then correlation and causality with small samples. So there is big data, small data challenge exists very much in our world, even today. And then the world is interconnected. So we are talking about networks. Again, when we talk about AI and data sciences, sometimes there is a tendency to draw this line. What is data sciences and what is or is not AI? These kind of things are very hard for me to answer. From my own perspective, here is something that I took from somewhere in Medium. So this is just one person's view of the history of AI. So just to give an idea, here is where I started when I during my PhD work. This was late 1990s, early 2000s. This was a paper from my dissertation, and this did look at different kinds of physics and statistical methods, as well as artificial neural networks, to come up with short-term precipitation forecasting, what is called nowcasting. And then recently, just last year, and last year, one of my PhD students, together with others, including stakeholders, developed this, what we call trustworthy AI. This is hybrid physics AI for the same problem, numerical weather prediction, more in the context of precipitation nowcasting. The thing is, these are both, you could say, both physics and AI. The physics has changed somewhat, maybe not as much, but the AI has changed completely. So that's interesting how these fields have evolved over time. And if you look at the top left, where I say history of AI, I sometimes call this a personal history of AI in the context of precipitation nowcasting. So let me take you through what that means. So 2003 was when that paper from my PhD dissertation was published. There were a few groups working on precipitation nowcasting, including with AI or data science methods then. After a lull, or not that much happening in this field, 2021, Google came up with deep generative models of radar, where they said they outperformed the state of the art, but they are not very good for extremes or for convection. Then Tsinghua University, together with UC Berkeley, came up with what they call NowcastNet, which outperformed DGMR, this earlier model by Google, and it was better for extremes and convection. So what was the difference? Well, one on the left that Google claimed was physics-free deep generative model. The one on the right was physics conditional deep generative model. And what the physics did here is improve the prediction for extremes. Machine learning, of course, needs a lot of data, but for extremes, by definition, these are rare events. We don't have enough data. And it turns out, at least in this case, that conditioning with physics improves that. By the way, both of these were untested for the end applications of hydrology and water resources. That's something that we did. We worked with stakeholders in Tennessee Valley Authority, and we got some good, we worked with them, we co-developed, co-designed an approach with them, developed metrics for them, and this is a quote: the hybrid physics AI precipitation nowcasting method and corresponding metrics developed by our team. Our team was funded by NASA, hold promise and is being currently tested on the Tennessee Valley Authority's operational river forecast system. So I'll not be able to go through all my students here, but here are all my students. On the bottom right, that's the mayor of Boston and the governor of Massachusetts. Everybody else is a student. On the left, this is part of my entire lab visiting the United Nations for an invited workshop. In terms of what we have done for the real world, from laboratory to communities and maybe our planet, we have worked with Climate Ready Boston in terms of assessment of what needs to be done for climate. We have worked with the town of Brookline, Massachusetts, for heat waves and public health risk, and our work has informed their own assessments. And then we have tried to what we call break through the maladaptation cycle, this vicious cycle of financial disincentives, policy myopia, outdated best practices, and engineering stagnation. Our thesis has been that financial incentives and transformation science can help us break through this. There have been examples before, 20 to 30 years back. There have been examples in insurance tech where modeling of natural hazards, natural perils, and these models were called catastrophe models or NatCat models, natural catastrophe models, started by somebody called Karen Clark in Boston. It was called AIR Worldwide then, and then 6 months later, Hemant Shah in RMS, Risk Management Solutions. So these have been some of the pioneering work in these areas. They faced a lot of skepticism initially, but they are now the industry standard over the last 20, 30 years. So what we have been doing from our lab is something similar, but trying to embed climate. So here is something, this Northeastern startup, this came out of my lab, which was a successful startup that was able to embed climate in the municipal bond market. And the idea was that we have physics, data sciences, including but not limited to machine learning in terms of the technical edge, but the marketing pathway was through municipal bond market, rating agencies and such. And this was highlighted in the Wall Street Journal. Here is my former PhD student, Evan Kodra, and I was also involved in this. It was sold to Intercontinental Exchange, which owns the New York Stock Exchange. And as a follow-up to that, many other startups were launched from my lab. This is Kate Duffy and Thomas Vandal, TJ. They started a weather AI startup. This is Jack Watson. He started Enodia, which is for infrastructure resilience. This is Udit Bhatia. So the first three are based in or around Boston and Massachusetts. This one is based in India. Udit is a faculty at IIT, and all of them are my PhD students, by the way. And I'm involved in some way or the other with all of them. This one focuses on resilience with AI, especially flood prediction and flood-based resilience of infrastructures. We also have deep connections across the world. So we are part of India's monsoon mission phase 3. We have a project there. I have a student funded by Indonesia, PhD student, and we have strong connections with the Indonesian government, and we have connections across the world from Africa to South America and of course Asia. And AI discussion is probably not over until I also talk about the pitfalls and ethics. So AI has been called all the way from the new electricity to end of humanity. Here is an article. This is an interesting blog article that talked about how AI is helping scientists bring some order to the chaos of their work. So how different scientists, this is Tapio Schneider from Caltech, talked about faster, more satisfying and better solutions. Claire Montiglioni from University of Colorado and INRA, France, talking about hallucinations and model granularity. Aditya Grover from, I believe, UCLA, talking about from an AI purist, why too much physics can also be a bad thing. And they also quoted me about the need to make AI trustworthy. And of course, we have a lot of different opinions about AI. So the most important thing that humanity has worked on to AI is the new electricity, all the way from if anybody builds it. This is, of course, they're talking about superhuman intelligence, AGI. Then we are all killed, and development of full AI could spell the end of the human race. But beyond those, there are other things, other smaller things, such as data centers are big and very important for AI, and they deplete water and they have huge demands on power. Here is Gemini AI. I asked Gemini AI to list AI challenges, and I think it did a pretty good job, at least at a high level, from bias and discrimination to transparency, lack of transparency, job displacement, etc., and also major ethical issues from fairness, security, and environmental impact. But one thing I wanted to highlight, let me make a connection and analogy with an atomic bomb that was dropped, for example, in Hiroshima and Nagasaki. Let us ask ourselves, who first decided to drop the atomic bombs on civilian populations? And this is not a judgment call on what needed to be done or what needed to be done, but who makes those decisions? It is not the technology, it is the humans. So question here becomes, who will control who will control AI? Will it give too much power to too few people? And will those few people make the right decisions for all of humanity? With that, thank you very much. Happy to take questions later.